So hi everyone, welcome back to another video, and today we're going to be solving Cambridge IGCSE Chemistry Paper 3 Theory Core May-June 2024 Paper 33. And if you guys are O-levels students, then this video is really going to be helpful for you guys, because after the recent syllabus updates, the Cambridge IGCSE syllabus and the Cambridge O-level syllabus is exactly the same. So this video might provide value to you guys as well and help you practice the syllabus more. Okay, let's get started. Figure 1.1 shows the structures of 7 substances A, B, C, D, E, F, and G. Okay, we have 7 substances right in front of us. Let's figure out the substances. Okay, for substance A, I can see that we have 2 carbons, so it's C2 and 4 hydrogens. 1, 2, 3, and 4. So that's simple C2H4, and I have a double bonded carbon at the center, so I know that this is my ethene molecule because it has 2 carbons. 1 carbon is meth, 2 is eth, so it's going to be ethene. So next I simple have my HCl, which is an acid. You guys must know this. Okay, next I have 1 carbon with 1, 2, 3, 4 hydrogens, so that is my CH4. CH4 is simple methane gas. Take care. Next I can see that I have a kind of a 3-dimensional structure, and I can see that my 1 atom is bonded to 4 other atoms. Okay? If I take this, it is bonded to 1, 2, 3, 4, and this structure resembles the structure of another kind of an element, which is diamond. Diamond is an element, remember. Why diamond is an element? Because diamond is made up of solely carbon, and carbon is an element. So never consider diamond as if it's a compound or something. Though it is a giant covalent structure, there's no doubt in it that diamond is a giant covalent structure. What do I mean by giant covalent structure is that, can you see this atom attached to all other atoms by these strong covalent bonds? These are basically extremely strong bonds that are between the atoms. Okay, these bonds, these lines, these are extremely strong covalent bonds that have attached these atoms together, so it forms a giant covalent structure of a lot of covalent bonds. Okay, let's move on to the next part, which is E. Okay, E is a simple ethane molecule. We have C2 and H1, 2, 3, 4, 5, and 6. H6, and I know that it's simple ethane, which is an alkane. Okay, I also know that ethane is an alkane, and that's simple. It's a simple molecular structure. Ethene is also a simple molecular structure. Then F is simple ammonia gas, NH3. How do I know this? I know I have 1 nitrogen and 3 hydrogens, so it's NH3, and my NH3 is ammonia gas. Okay, NH3 is ammonia gas, and I know when I'm going to be questioned below, I know that they might ask me some properties of ammonia gas, like it forms an alkaline solution or something. So I should know that ammonia gas forms an alkaline solution, and a few properties of ammonia gas, that how it is formed. Ammonia is formed from nitrogen and hydrogen, and it forms ammonia, NH3, and to balance it out, you put a 3 over here and a 2 over here. Okay, next part G is very interesting, because in part G I have my iodide ions. Don't call them iodine, they're not iodine. When they have a negative sign with them, they have turned into iodide ions. And I have my sodium ions. Now my sodium ions and my iodide ions are basically attracted towards each other. One is my negative ion and sodium ion is my positive ion. I have negative and positive ions. I have a giant ionic lattice of, this is a lattice of positive and negative ions. Okay, and this is a giant ionic compound. Why? Because if I have ions, I have negative ions, I have positive ions that are joined together by strong electrostatic forces of attraction. So that's going to be a giant ionic compound. It's a compound. Remember, this diamond is an element. This one is an element because it only has carbon. It has no other substance than carbon. Whereas this G part is a giant ionic compound. Why? Because it is a compound. It has sodium as well as iodide ions in it, which make it a compound. Okay, let's move on. By reading the question, answer the following questions using only the structures in figure 1.1. Each structure may be used once, more than once, or not at all. State which structure represents a compound that is the main constituent of natural gas. You should know that natural gas is basically methane, CH4. Do you guys remember that natural gas at our homes is basically methane? Okay, so what is methane? We figured out all of them, and we figured out that our structure C was methane. This one right here is methane, so that's going to be part C. The monomer used to produce polyethylene. Okay, poly part represents that it's a polymer, and ethene tells us that the monomer used to make it is polyethylene. For example, I have polystyrene. Okay, I'm just telling you how these polymers are written. Polystyrene tells me that this is a polymer because it has poly in it, and the monomer used is the word after poly. So styrene is the monomer used to make polystyrene. Okay, styrene is the monomer used to make polystyrene. If I have polyvinyl chloride, okay, if I have polyvinyl chloride, and if I ask you what is the monomer used to make polyvinyl chloride, so in this part, poly tells us that it is a polymer, and vinyl chloride tells us that this is the monomer used to make the polymer. This vinyl chloride is going to be the monomer. So in polyethylene, ethene is going to be the monomer that's used to make polyethylene. After the word that comes after poly is basically your monomer used to make it. So we just identified the structure of ethene, which was part A. That's ethene, so it's going to be A. Okay, is a giant covalent structure. We only have one giant covalent structure above, which we identified, which was part D, that resembled the structure of diamond, which was giant covalent because carbon atoms attached to other carbon atoms through strong covalent bonds, making it a giant covalent structure. So that's going to be D. Okay, next we have a compound that has high melting and boiling point. Not boiling point, only high melting point. Okay. You might think that D is a compound with high melting point. Well, that's correct. It has high melting point, but it's not a compound. Look, diamond is only made up of carbon, and carbon is an element. It cannot be a compound. It has high melting and boiling point. It has a melting point above 3000 degrees Celsius. Okay? So the melting point is above 3000 degrees Celsius of diamond. But the thing is that it's not a compound, it's an element. So a compound with high melting and boiling point is going to be G, because G is a giant ionic compounds, and we know that ionic compounds have high melting and boiling points, and G is basically a compound. This is an element, and in the question we were asked about a compound, so it's going to be G. As we know that these iodide and sodium ions, they're basically attached to each other by strong electrostatic forces of attraction, and these forces are STATIC. These forces are extremely strong. Okay? There is strong attraction between these that needs high amount of energy to be overcome, so giving it a high melting point. Let's move on to the next part, which says a waste gas from digestion in animals. Well, that's clearly stated in the syllabus that the waste gas that we get from animals is methane gas, CH4. So it's again going to be part C, that is methane gas that we get from the digestion in animals, a solid at room temperature that conducts electricity when dissolved in water. Okay, it is a solid at room temperature. Let's first figure out all the solids we have at room temperature. But it will only conduct electricity when dissolved in water. It will not conduct electricity in the solid state. Okay, let's figure out. Firstly, ethene will not conduct electricity at all. It's a simple ionic structure, and simple ionic structures are bad conductors. What do you think about hydrogen chloride? Okay, I'm going to tell you about this later on. Let's first discuss the other parts. Methane is a simple covalent structure, won't conduct electricity. Obviously, Diamond is a giant covalent structure and it cannot conduct because it does not have any free electrons. All electrons are involved in forming covalent bonds. Obviously, ethane is also not going to conduct. Ammonia gas is not going to conduct. It's a gas. Okay, now we're left with two structures. We have HCl and we have this G part. Now the problem is that HCl, when dissolved in water, is going to form H plus ions and Cl negative ions. And well, these are ions and they're going to be mobile, which means they're going to be able to move freely. So this can conduct electricity in aqueous solution. This can conduct because what will happen is it will ionize. But the problem is that the question states that the substance we're looking for should be a solid at room temperature. If you know the physical state of hydrogen chloride gas is that this is a gas at room temperature and you dissolve it in water to form HCl solution. So if we need a solid, we got to take structure G. Structure G is a solid at room temperature because that's an ionic compound, and when we dissolve it in water, we're going to have free sodium ions and iodide ions, and these would be able to move freely through the structures to the aqueous solution and conduct electricity. So that's going to be G because it's a solid at room temperature and will conduct electricity after it is dissolved in water because it's going to ionize. Ionize means that it's going to form ions and those ions would be free to move. Let's move on. Next question says complete figure 1.2 to show the dot and cross diagram for structure B. Show the outer electron shells only. Okay, now we know that chlorine is in group 7, okay, and we also know that hydrogen only needs one electron. Hydrogen basically has one electron in its outermost shell, and it needs one more to complete the outermost shell and to get a complete of 2 electrons. So what will happen is that this cross is the electron of hydrogen. Now hydrogen just needs one more, so it will share one pair of electron. And chlorine is also in group 7, and in order to stabilize, an atom needs 8 electrons. Chlorine just needs one more electron, plus 1. Just plus 1 to reach 8. So what will chlorine do? Just form one covalent bond, which it has already formed with this hydrogen. Hydrogen also needs to form just plus 1 electron, it needs to get 2. Okay, because hydrogen only has one shell and the maximum capacity of the first shell is 2, whereas chlorine has more shells, so maximum capacity of the last shell of chlorine is going to be 8. Okay, so chlorine is now gonna make one pair to have complete 8 electrons. Okay, out of these 7 electrons, now 1 electron is used. This 1 dot was the electron of chlorine. This 1 dot has been used to make a covalent bond with hydrogen. So how many are left? 7 minus 1, that's going to be 6. So we have to show all the outer electrons, so we have to show the 6 unbonded electrons in chlorine as well. Okay, these are the lone pairs 1, 2, 3, 4, 5, 6, and these are important in order for the complete 2 marks. And in hydrogen there are no other electrons, it only had one cross. And make sure that if you're using cross for hydrogen, it's only for hydrogen. For chlorine you have to draw all the dots, it cannot be a mixture. Okay, let's move on to the next part, which says that intracellular fluids in the solution between the cells in the human body. Table 2.1 shows the masses in milligrams of some ions in 100 cm cube of intracellular fluid. Okay, answer these questions using information from table 2.1. Name the positive ion that is present in the lowest concentration. Okay, the first part is I have to identify a positive ion and then that is present in the lowest concentration. Among all these, what are positive ions? This is a positive ion, I can see a 2 plus. This one right here is negative, this one is a positive ion, this one's a positive ion, and this one is the positive ion. I figured out all the positive ions. Now I have to figure it out which is in the lowest concentration. Okay, I look all of their concentrations. Okay, I have 6, 31, 6, 24, and 23. So it's basically calcium, which is in lowest concentration. That's 6. So I'm gonna write, it's gonna be a calcium ion. Okay, name the ion that contains an element in group IV. IV means group 4. How do I know in okay, I means 1 and V means 5. Now I'm going to tell you one hack, that when this I is written before V means on the left side of V, we subtract it from V. So 5 minus 1 is going to give us 4. And when this I is written in front of V, we add it. So 5 plus 1 will give us 6. So VI means 6 and IV means 4, because we subtract this one because it's written on the left side, and when this one will be written on the right side, we'll add it. So this is in group 4, in that contains group 4 of the periodic table. Now for group 4, we just go to the periodic table, figure out all the elements that are in group 4, and then on that basis we can identify the... Okay, these are the group numbers at the top. This is my group 4. I'll figure out all the atoms. I have carbon, I have silicon, I have germanium, tin, lead, and this, whatever, this is not part, so I'll only consider these 4. We have carbon, silicon, germanium, tin, and lead. Now let's figure out what do I have among them in my table. I have to figure out one element. Do I have carbon somewhere? Yeah, I have this carbon over here. In this I have carbon. Okay, do I have silicon? Do I have germanium? Do I have tin? No, I don't have anything except carbon, so it's going to be hydrogen carbonate ion. So name the ion that contains element in group 4 is going to be hydrogen carbonate. Okay, describe the test for sulfate ions. For sulfate ions, first you just got to learn it for the qualitative analysis. That's a compulsion, so just learn it. Acidified with nitric acid. Acidify it with nitric acid. Then add barium nitrate, and then you're going to see that white precipitates of barium sulfate are going to form. Okay, that's the test for sulfate ion. Small amounts of ammonium ions, okay, and chloride ions are formed in some cells of the body. State the formula for compound that contains ammonium ions and chloride ions. Okay, ammonium ion is basically NH4 plus and chloride is Cl negative, so these will cut out, +1 and -1, so it's going to be NH4Cl. That's going to make it ammonium chloride. And we had to state the formula, so I've written down the formula. Don't write the name ammonium chloride, that's not going to gain you mark. Okay, choose from the list the salt that is insoluble in water. All nitrates are soluble, so not this. Lead chloride, wait for this. All potassium salts are soluble, not this. All sodium salts are soluble. Just state the solubility rules while reading out. All chlorides are soluble except for lead and silver, so this is going to be insoluble because that's a lead chloride. That's an exception. Let's move on. Table 2.2 shows some properties of the group 1 metals. Okay, we have lithium, sodium, potassium, rubidium with their hardness. Okay, and we see a general trend in hardness, that hardness is decreasing. Okay, observations on reaction with water. And now predict the hardness of potassium. What do you guys think? Obviously, as we know that the hardness is decreasing, so the hardness of potassium is going to be less than 0.69 because the trend is that it has to decrease. So it might be, you can just write any value between these two values. It can be 0.42, for instance. I'm writing that's just like random value. You can write any value. You have a range of values in the marking scheme. Let's move on. Okay, 0.42. Describe the observation when rubidium reacts with water. Okay, for lithium we have bubbles form very slowly and no flame. Sodium bubbles form very rapidly and flame. So there's going to be bubbles, explosion, because there's going to be a high flame as we see that the reactivity is increasing. First it's very slowly, then it's again very slowly, then it becomes rapidly, and then it's going to be an explosion. You can write flame, you can write bubbles, you can write 3-4 observations, something like this, like bubbles extremely rapidly, or something like extremely rapidly, something like this, that shows the intensity is increasing, okay, as we're going down the group. So you just write bubbles very rapidly with explosion. Okay, explosion means that there's a flame as well. Okay, sodium reacts with hydrogen to produce sodium hydride. Complete the simple equation for this reaction. Okay, hydrogen, it's going to be H2, and obviously you're going to add a 2 over here, and done with it. Let's move on. Define the term electrolysis. Just learn the definition of electrolysis. It's a very widely tested definition. I totally recommend spending, just 2-3 minutes on learning it. It is the decomposition of an ionic compound in decomposition of an ionic compound in molten or aqueous state by the passage of electricity. Just learn this definition, by the passage of electricity. Okay, the next is name an inert metal that can be used for the electrodes. Obviously that is going to be platinum. Why it's going to be platinum? Because you might think of graphite, but they have asked of a metal, and a metal is platinum. If you write graphite, that's going to be incorrect, because graphite is carbon and carbon is a non-metal. Okay, name the product formed at each electrode. Okay, molten calcium bromide, calcium and bromine. Positive electrode is your anode, negative electrode is your cathode. At cathode you have your cation or the positive ion, that is going to be calcium. Positive ion is going to deposit, and at the anode you're going to have, it was calcium bromide, so you're going to have bromine going to be formed. Okay, calcium reacts with water and alkaline solution is produced. Name the ion which causes the solution to be alkaline. Simple, it is calcium plus water, that's going to form calcium hydroxide, which is alkaline, thus hydrogen gas. This equation is not balanced, just add it over here and now it's balanced. So basically this calcium hydroxide solution is what makes it alkaline, okay? And hydrogen gas is also produced. So name the ion which causes a solution to be alkaline, so it's going to be hydroxide ion. Don't write calcium hydroxide, because we have to name the ion which causes the solution to be alkaline. It's not the calcium ion, it's only the hydroxide ion. Okay, choose the pH value of an alkaline solution. Alkaline solution have pH value greater than 7. Okay, they have pH value greater than 7. So not 1, not 5, not 7. It's going to be 9. That is greater than 7. Okay. Dilute hydrochloric acid is added to a solution of litmus in alkaline solution until the acid is in excess. Okay, we have dilute hydrochloric acid and we have added it to a solution of litmus in an alkaline solution. Okay, what they're saying is that you have this beaker, this conical flask, and you have an alkali in it. Okay, the alkali may be anything, and now you add acid to it in excess. So first for alkali, the litmus is going to be blue, and then you add acid in excess until the acid in excess, that's going to be red. Okay, because litmus is red in acid. Just learn the colors for methyl orange, litmus and thermophthalene, and blue and alkali. Okay, let's move on. Calcium carbonate is added to the blast furnace in the production of iron. Calcium carbonate breaks down when heated to produce calcium oxide and gas that turns lime water milky. Name the gas that turns lime water milky. That's easy. It's carbon dioxide gas. How do I know? That's simple. Call it the test for anions. The test for gases, just learn all of them. The test for carbon dioxide gas is that it turns lime water milky. Okay, name the type of chemical reaction that takes place when calcium carbonate is heated. Okay, sorry for this. Okay, whenever calcium carbonate is heated, CaCO3, what happens is it decomposes to calcium oxide and carbon dioxide. So this is the decomposition of calcium carbonate. Okay, basically this calcium carbonate is decomposing into calcium oxide and carbon dioxide. So this reaction is called, type of chemical reaction is thermal decomposition. Why thermal? Because we are providing it with heat. It is heated, that is why it is going to be thermal decomposition. Chlorophyll is a colored compound found in plants. Chlorophyll is needed for photosynthesis. Complete the word equation for photosynthesis. Okay, photosynthesis is simple. You take carbon dioxide, you take water, and you form glucose and oxygen gas. Okay, simply write glucose and oxygen, and you're going to gain mass. State one other condition that is essential for photosynthesis. Okay, the two essential conditions, one is chlorophyll and one is sunlight. Or you can simply write light. Yes, several other colored compounds are found in plant leaves. A student extracts a mixture of colored compounds in a plant leaf. Figure 4.1 shows the apparatus used to separate the colored compounds. Name the method of separation. Okay. Now this is the apparatus the student uses, and this we know that the solution of methyl ethanol in methanoic acid. This is the solvent the student has taken. This is the mixture of the colored compounds. And name the method of separation. That is simple. Chromatography, as we can see it. Okay, there is no rocket science in it. Simple chromatography going on. Suggest why the baseline is drawn with the pencil and not ink. The reason for that simple. That pencil is insoluble. Pencil is insoluble. Now I'll explain you guys one thing, that whenever we use ink, for example, this is my chromatogram and I place a dot with ink, not a dot, I draw my baseline with ink. Okay, what will happen is that ink is itself is a mixture of dyes. So in my solvent, ink might dissolve and ink might disturb the chromatography and might move up. Okay, ink is itself a mixture of dyes. Ink is itself a mixture of dyes and ink might dissolve and disturb the chromatography. Okay, so we cannot use ink. We use pencil because it is insoluble, whereas ink dissolves. Ink is itself a mixture of dyes. The liquid used to separate the colored components is a solution of methyl methanoate in ethanoic acid. State the meaning of the term solution. A solution is basically when a solute dissolves in a solvent. Okay, and that forms a solution. Solute is basically, for example, if you're making a salt solution, so your salt is gonna be your solute and your water is gonna be your solvent. That's simple, less lame ass example of solute and solvent, that the salt is going to be the solute, water is going to be the solvent, water is going to dissolve salt, and you make a solution of salt. Figure 4.2 shows the displayed formula of a compound found in plant cells. Draw a circle around the alcohol functional group. Alcohol functional group is OH. Okay, now let me figure out. Okay, some of you might think that this one is an alcohol functional group. Someone of you might draw it here. Someone of you might draw it here. All of these are incorrect. Why they're incorrect? Because they're not alcohol functional groups. They are, if you look at them carefully, they are carboxylic functional groups with OH. This is not an alcohol functional group but a carboxylic functional group. Okay? So if you draw a circle here, here, or here, it's gonna be incorrect. Only the alcohol functional group here is this OH because it's alone. When OH has a carbon and double bonded oxygen, that's not an alcohol functional group but a carboxylic functional group. So all these three are incorrect. Okay, let's move on to the next question, which says an atom of phosphorus is represented by the symbol shown. Describe this atom of phosphorus in terms of the position of the electrons and neutrons, protons in the atom. Okay, it's simple that on the lower left side, this over here is the proton and electron number, because in a neutral atom proton and electron is same as the proton and electron number. Okay, then on this top right here, 31, we have the mass number. Okay, this 31 is the mass number, that's the number of neutrons. So on the top left is mass number, but they've asked in terms of electrons, neutrons, and protons, so we're just going to take mass number. Okay, so is mass number, which is combined mass of protons and neutrons. Okay, protons and neutrons, you know that this is the combined number of protons and neutrons. To get 31. Okay, now the next part is that the number of neutrons and the number of protons. Proton obviously is going to be 15, we know, and neutrons is going to be 31 minus 15, that's going to be 16. So we have 16 neutrons. Okay, just write it in word form. Over here is the electronic configuration. We know that in a neutral atom the number of protons and neutrons are equal, the number of protons and electrons are equal, so this is the proton number, so we're going to have the same number of electrons, so We know that phosphorus is in group. We can check out the group of phosphorus right from the periodic table here. As we know that phosphorus is in group 5, so the last shell will have 5 electrons, that's for sure. And now we can simply draw the electronic configuration of phosphorus. The last shell will have 5. We have to complete 15, so 2 and 8. 2, 8 makes it 10, and 5 in the last shell, 15. Complete the simple equation for the reaction of phosphorus with oxygen. ठीक है. We take a 4p over here, and that's a 10, so we take a 5 here. 5 2 times 10, that's balanced. Show the displayed formula of a compound of phosphorus. Deduce the molecular formula of this compound. We simply have to count the number of atoms. First, let's count the phosphorus. 1, 2 and 3. So we have P3. Now let's count out nitrogen. That is 1, 2 and 3 as well. So that's gonna be N3. And now we have chlorine, so let's count at the chlorine. 1, 2, 3, 4, 5, 6. So we have Cl6. Just copy it down to here. Okay, P3 and TCl6. Let's move on. Another compound of phosphorus has the formula Na3PO4. Okay. Complete table 5.1 to calculate the relative formula mass of Na3PO4. Okay, we have Na3, phosphorus in it is 1 and oxygen is 4. We have to write the number of atoms over here. Relative masses were given. We just multiply the number of atoms with the relative mass to get the total mass. So 1 into 31 gonna give us obviously 31. 4 into 16 gonna give us 2, 4, 4, 1, so 5, 6, 64. So what are we just gonna do? We're gonna add all three to get the relative formula mass. 69 plus 31 plus 64, that's gonna give us 14, and 6 plus 6, 12, 13, 14, 15, 16. So that's gonna be 164. Just go check it out from a calculator, and I guess that's correct. Okay, phosphates in reverse can cause deoxygenation of water. State one source of phosphates in reverse. That's simple. It comes from the fertilizers. Phosphates and nitrates are used in fertilizers, and they come from the fertilizers into the rivers and cause the deoxygenation of water because they're used for the plant growth and fertilizers. Okay, next question. Dilute hydrochloric acid reacts with small pieces of calcium carbonate. To state the meaning of the state symbol AQ. AQ means aqueous. Okay, L means liquid, and G means a gas. Just learn these. Okay? AQUEOUS. Just don't mind the spellings, because in a chemistry exam there are no marks for the spellings. Okay, figure 6.1 shows how the mass of small pieces of calcium carbonate changes as the reaction proceeds. The calcium carbonate is in excess. Okay. Reduce the mass of calcium carbonate 2 minutes from the start of the reaction. Okay, that's the mass of calcium carbonate. 2 minutes after the start. Draw a straight line at 2 minutes. Okay, this right here is 5, so it's going to be 4.12, 4.3456. So it's 4.6 grams. Grams I got from here. Okay. Next is explain how the graph shows that calcium carbonate is in excess. Okay, the graph shows that calcium carbonate is in excess because even after all the time has been finished, there is still some mass of calcium carbonate that remains. 1 gram masses still remain. Even after the line got flat, we still have mass of calcium carbonate. So even after the reaction has finished, we still have time is, this is flat. This means time is passing but mass is not reducing. We still have 1 gram left. So even after the reaction finished, still 1 gram of calcium carbonate left. Okay, this shows that it was added in excess. Okay, the experiment is repeated at higher temperature. Now we are increasing the temperature. That's going to for sure increase the rate. All of the conditions stay the same. Draw a line to show the mass of calcium carbonate changes at higher temperatures. Okay, remember that temperature does not affect the yield of the product. The amount of product formed remains the same. What really changes is it becomes faster. So what's going to happen is I'm going to erase all this and show it to you guys, that some of you might think that if we increase the temperature, what will happen is that now this is going to be faster. No, the mass line will remain the same. Okay, the amount of mass will remain the same. What will happen is that it will happen a bit quicker like this, but you cannot change the mass line. It's going to be something like this. Okay, you cannot put it like this. Okay, this is wrong. This is wrong, because higher temperature does not means that higher product yield, change in the reactants, nothing like of that sort. It simply means that the reaction is just going to happen a bit earlier. So it's going to be something like this. To get that means that now the reaction is ending over here, which is 2.2 minutes, and over here the reaction was ending somewhere here 4 point some minutes. Okay, the reaction ended a bit earlier, like 2 minutes almost earlier, but the amount of the calcium carbonate remained the same. The amount we cannot change with temperature. Okay, we can only change the time with temperature because it will happen a bit earlier. Describe the effect, if any, on the rate of the reaction when large pieces of calcium carbonate are used instead of small pieces. Obviously the rate will decrease. Rate means the speed. Why will it decrease? Because look, this is a large piece and these are all the small pieces of calcium carbonate. Now look at the surface area. I'm drawing the surface area with green. This is the surface area of the large piece and this is the surface area of the small pieces. Now look, which has a larger surface area? Obviously the small pieces have more green surfaces, so the small pieces will react more fast and the rate will be more. For a large piece, when the large pieces are used, the rate will decrease. Okay, increasing the concentration of hydrochloric acid increases the rate of the reaction of dilute hydrochloric acid with calcium carbonate. Choose the correct unit for concentration. Draw a circle. It is mole per dm cube. That is what we use for concentration. Concentrated hydrochloric acid gives off hydrogen chloride gas. Hydrogen chloride gas is an acidic that turns stamp universal indicator paper red. A long glass tube is set up as shown in figure 6.2. Hydrochloric acid, HCl, universal indicator paper, it will turn it red. At first, universal indicator paper does not change color. The universal indicator turns red after a short time, because what will happen is that this hydrogen chloride gas, basically, which is over here, in this container, after some time it will surely evaporate and spread throughout the container like this, and it will reach the universal indicator paper, and obviously being an acid will turn the paper red. That's what's basically happening. Explain these results in terms of kinetic particle theory. Okay, that's easy. That according to kinetic particle theory, the particles of HCl, what is basically happening? What do you guys think about this? Don't you think it's diffusion? Particles from here, where they're in higher concentration, move to area where they're in lower concentration. So that is diffusion. Simply diffusion is occurring. So I'm going to write that according to kinetic particle theory, HCl particles with higher energy escape from the, escape from the concentrated, from the HCl solution, and move from area of higher concentration to area of lower concentration, spreading throughout the test tube. What was this? Was this a test tube or whatever? Long glass tube. So spreading throughout the glass tube, hence turning the universal indicator paper red. ठीक है. Okay, hydrogen chloride breaks down to form hydrogen and chlorine at 1500 degrees Celsius. The reaction is endothermic. State the meaning of the term endothermic. Endothermic means that it absorbs thermal energy. Thermal energy is basically heat energy. Exothermic means that it will give out thermal energy. Endothermic means that it will absorb thermal energy. Learn this definition. Okay, that's the worst color combination, I guess, green and red, but still learn this definition that endothermic absorbs heat energy, exothermic releases heat energy. Okay, that's simply 1 mark into the bucket by learning the definitions. Okay, chromium and iron are transition elements. They're ductile and have, the properties given to us are ductile and have high melting and boiling points. State 3 other physical properties of chromium. Okay, chromium and iron are transition elements, so they formed, learn these by heart, they formed colored compounds. They will have variable oxidation states. They can be used as catalysts. Done. Okay, because all transition elements can be used as catalysts, they're variable oxidation states and they form colored compound. That's simply the properties of transition elements I've stated over here. Okay, the formula of rust is this. State the chemical name of rust. The chemical name for rust is hydrated iron 3 oxide. How do I know it's iron 3 oxide? Because this 3 over here tells me that there was a plus 3 over here in front of iron. This 2 tells me there was a negative 2 over here. First of all, I have water, so that's going to be obviously hydrated. I have my oxygen, so that's going to be an oxide of iron 3 because iron has a charge of plus 3 in it. Because this 3 underneath comes over here, this 2 comes over here. So oxygen has negative 2 and iron has positive 3. So hydrated iron 3 oxide. An iron object is coated with plastic. Explain how this prevents iron from rusting. Okay, plastic prevents oxygen in air, because oxygen is what will react. Oxygen and water to reach the surface of iron. Okay, surface of iron. That's how plastic will prevent it. Okay, plastic cannot do sacrificial protection because it's not a more reactive metal. For that, you use zinc or some other metal that is more reactive. What basically plastic does is that if this is your iron, a plastic will form a layer over it, something like this green layer, and now the oxygen and water won't be able to reach the surface of the iron. So plastic prevents oxygen, water to reach the surface of iron, and this is basically a barrier method. What do I mean by barrier method? I'm writing in bracket that plastic forms a barrier. It's not sacrificial protection, that's something else. It's a barrier method, that a barrier between water and oxygen and the iron. Okay, chromium behaves as a typical metal when it reacts with sulfuric acid. Complete the word equation for this reaction. Typical metal plus acid. What are the products? Metal plus acid, salt plus H2 gas. So over here we're going to write hydrogen, and over here we're going to write the salt. That's going to be chromium sulfate. Okay, chromium sulfate. Let's move on. Okay, the list shows 5 metals. Put these metals in order of reactivity. Put the most reactive metal at the top. Okay, you can only know this reactivity if you learn it. Okay, there is no other shortcut to know this reactivity. I know it because I've learned it. So first it's going to be calcium because it's in group 2. Then it's going to be aluminum. Then it's going to be zinc. Then it's going to be iron, and then it's going to be copper. That's simply how you're going to know it by learning it. Okay, just learn the reactivity series and you're going to know it. So the next question basically says that zinc can be produced by heating zinc oxide with carbon. ठीक है, describe how this equation shows that zinc oxide is reduced. Reduction is basically the loss of oxygen. ठीक है, over here we see that zinc oxide had oxygen. ठीक है, this is zinc, this is oxygen. But then zinc lost its oxygen and it only became zinc. First it was zinc oxide, ZnO, then it only became zinc. So we're going to say that it is simple reduction because zinc oxide has lost oxygen. ठीक है, and it formed zinc. To form zinc, which is Zn. ठीक है. Let's move on to the next question, which says this question is about hydrocarbons. Table 8.1 shows the names, formulae, and boiling points of methane, ethane, propane, and butane. Use the information in table 8.1 to answer these questions. Name the homologous series that includes methane, ethane, propane, and butane. Okay, ane part tells us that these are all alkanes homologous series. Alkanes. Okay, state the trend in the boiling point of this homologous series as the number of carbon atoms increases. Okay, we can see that the boiling point is also increases. You should know that in negative numbers, negative 164 is a smaller number. Negative 88 is a bigger number, so it's increasing. And 0 is the biggest of all these. So, the trend is increasing as the number of carbon atoms increase. So, because methane has 1, eth2, prop 3, but 4. So as the carbon atoms increase, the boiling points to increase. ठीक है? Reduce the general formula of this homologous series. We don't have to reduce it, we know it, that it's CnH2n plus 2. ठीक है? Complete the word equation for the complete combustion of ethane. That's ethane plus oxygen forms water plus carbon dioxide. Okay, and we are given 2 lines to write carbon dioxide. Next is long chain hydrocarbons can be cracked to produce alkenes and hydrogen. State 2 conditions of cracking. First, you need heat for cracking, and second, you need a catalyst. Okay. The diesel oil fraction from the fractional distillation of petroleum can be used for cracking. Give one other use of the diesel oil fraction. Diesel oil is basically used in trucks. Okay? Trucks, it's used to power trucks and buses. Okay? Large vehicles. Alkene molecule can react together to produce polymer. Define the term polymer. Polymer is basically a long chain organic macromolecule that is made up of short chain monomers. Okay? And with that we come to an end of our paper. You can just write that polymer is long chain macromolecule made up of short chain monomers. Okay? Or for more precise definition, you can just check out the syllabus in which it's clearly stated, and that's all. Subscribe to my channel and I hope you liked the video. Bye bye.